This video covers all of the problems in the EOG review on statistics and probability. Right, Susan recorded the time she ate dinner and the number of calories she consumed during dinner for 6 consecutive days. The results are shown in the table. Which best describes the association between the time Susan ate dinner and the number of calories she consumed? So if you look at the table, you have different times and numbers of calories. Such as 4 p.m. 600 calories, 5:30 p.m. 750 calories, and so on down the rows or down the columns. The thing is, the time you eat dinner and the number of calories you consume, one of them doesn't have anything to do with the other. So one of those variables is not dependent upon the other. If you were doing the amount of food that you ate and the number of calories, then one of those might depend on the other one. But the time that you eat and the number of calories that you consume there's no association there. So if we were looking for a positive association, as the time increased, the calories should increase. If we were looking for a negative association, as the time increases, the calories should decrease, and neither one of those happens. There's no such thing as an irrational association, so we would choose the pink answer choice, almost none. So if there were any kind of association, or it looked like there was any sort of a pattern, that would be a coincidence, because these two things really don't have anything, they don't affect each other in any way. All right, which equation best models the data shown in the scatter plot? So we've got some linear equations down here at the bottom. And the first thing that I want to do is I want to kind of maybe sketch or try to draw a line that would sort of match the scatter plot. So I'm going to start it right here, and I'm going to try to get it through the middle of that data to the best of my ability, and so somewhere around in there. And then what I want to do is I want to see maybe what the slope would be where I am right here. And so I'm going to choose some points so I can sort of get an idea of what the slope would be. I'm going to go with this point right here. This is at 100 and 15. And then I'm going to go up and see if I find another clean point right here where my line of best fit goes through. So my y values are changing by 25. Every time I go up one, that's 25. So if I count my rise, it's going to be 1, 2, 3, 4, 5. And that's 5 times 25. So that's 125. My x values are changing by 5s as I go to the right. So as I count I might have said run. I meant to say rise. I counted my rise, 125. Now I need to count the run. 1, 2, 3, 4, 5, 6. So that's 30. So let's see, 125 over 30 would be about 4. 120 over 30 would be 4. So I'm going to go with one of the ones that has a 4 for a slope. So 4x plus 5 or 4x plus 35. And my line of best fit started right around in here. So 4x and then plus what my initial value was. Well, I certainly did not start down here at 5 to do my line of best fit. I started at about 35 to do my line of, to start drawing my line of best fit. So I would say it would be the 4x plus 35 answer. Okay, this scatter plot shows the amount of sunlight some tomato plants received and the amount each plant grew. What is the meaning of the slope of the trend line shown on the scatter plot? So we have some answers down here that we're going to choose from, and obviously a tomato plant should grow according to the amount of sunlight it gets. Of course, there are some other things that it needs to grow, but sunlight should make it grow more. So as the hours of sunlight increases, the growth of the plant should also increase. So, and all of these choices down at the bottom say that the plant grows as the hours of sunlight increases. So we know that any of them could be a possibility. So let's look at our graph here, and we'll see if we can find. First of all, let's see, it starts at 0. So I'm going to go from the 0 to, we'll go to this point right here. That's pretty close to a clean point. So up 1, rises 1, and 1, 2, 3. So the way it's listed here is talking about the growth of the plant versus the hours of sunlight. So it looks like the plant grows about 1 inch for each hour, for each 3 hours of sunlight. So let's see if we have a choice that looks like that. Let's see, plant grows 3 inches. Oh, over here. A plant grows about 1 inch for every 3 hours of sunlight it receives, and that's what we got there. So that'll be that one. Henry made the scatter plot shown. The scatter plot shows the data points, and it also shows the linear model that Henry drew. So you see the data points and you see the trend line here. Which statement best describes the data? And this is calculator active. So let's look at the choices. The first one is the linear model describes the data well because the points are scattered above and below the line. We do have a couple points below the line, but most of them are above the line. So I'm going to say that's not the answer here. The next one, the linear model describes the data well because all the points are close to the line. They're not all close to the line. This one's an outlier right here. But let's look at our other choices. The linear model does not describe the data well because the line does not go through any of the points. It doesn't have to go through any of the points. Sometimes you'll have trend lines that don't actually go through any of the points, but it's still a good trend line. And then our last choice says the linear model does not describe the data well because most of the points are located above the line. And that is true. Most of them are above the line. So I would say if I were going to draw a trend line for this data, I might put it somewhere closer to, I don't know, maybe like right there. I might say that would be a better trend line than the one that they gave us. So it's going to be this last answer choice here. All right, a group of students were asked if they are in the math club and if they are in the literature club. Partial results are shown in the table. Let's look at the table real quick. So in the math club and in the literature club. So in the math club and in the literature club would be where this X is right here, because that lines up with both of the choices. So let's see. One of the students in the math club, 67% are not in the literature club. Of the students not in the math club, 78% are not in the literature club. What is the value of X plus Y? So we need to find X and Y, and this doesn't say whether it's calculator active. I'm going to assume it would be a calculator active problem because of the percentages. So we need to find X and Y and add those together. But to find the X and Y, we need to find these total numbers down here. That would be down here in this two-way table. So I need to find these two numbers first. So let's go with this part of the table first, okay? All right, so what we know is that there are X number of students in both the math club and in literature club, okay? There are 16 students in the math club that are not in the literature club. And we also know from our problem that of the students in the math club, 67% are not in the literature club. So what we know is that this 16 is 67% of some number. And I'm going to call that number N. I'm not going to call X and Y because we've got an X and Y in this chart already, or in this two-way table. So we know that 16 is 67% of this number down here, this total down here. Because of the students in the math club, 67% are not in the literature club.
So this number N down here would be all the students who are in the math club. Okay, so we're just going to set up an example, an equation up here. 16 equals 67% of what number? And when we see a problem like this, the word of always means times in math. So 16 equals 67% times N, or 67% N. So I'm going to grab my calculator, and I need to take a look at the scientific calculator. So if 16 equals 67% times N, then if we divide both sides by 67% or by 0.67, then we will find out what the total number of students in the math club is. So I'm going to go with 16 divided by, and I probably could do 67% here. I could. But I'm just going to put in 0.67. I just changed it to a decimal. That is 23.88. Let's round it to 24. So that means N equals 24. X and Y neither X nor Y equals 24, but N equals 24. So if this number right here is 24, and X plus 16 equals 24, then X must equal 8. Okay, so I've got X now. All right, so X equals 8, and I'm just going to keep this table small so we can see the other part. Of the students not in the math club, are in this column right here. Let me switch colors. They're in this column. Okay, so of the students not in the math club, 78% are not in the literature club, and that's this number right here. That means Y equals 78% of some number. Well, if I've got Y and I've got the other number and they're both unknown, then I need to really work with the number that I know. I've been given the number 4. So if this part is 78% of the total, well, 100% minus 78% is 22%. That means 4 equals 22% of that total number. Because remember, I'm looking for this total number down here. I'll call this M. So we found N by setting up an equation there, and N was 23. No, it rounded to 24, sorry. N was 24, so that means X was 8, because 8 plus 16 is 24. I need to find M now. So 4 equals 22% of that number M. So again, of always means times in math. 22%, I can rewrite that as 0.22. 4 equals 0.22 M. Divide both sides by 0.22. We'll grab my calculator. Clear that, and we've got 4 divided by 0.22. That is, we're going to say that's 18. We'll round it to 18. So M equals 18. Well, if M equals 18, and let me get rid of some stuff here, just so it's not so confusing. If M equals 18, and the total number of students, 4 plus Y equals 18, well, what plus 4 equals 18? That's 14. So that means Y equals 14. This is a good problem. All right, so what do they want to know? What are they asking us? What is the value of X plus Y? All right, so if X equals 8 and Y equals 14, I just need to add those two together, and that would be 22. So our answer is right here, 22. That was a fun one. Okay, how many people were surveyed? So what is the total number of people surveyed in this this survey right here? So we have males and females, we have what type of car, and then we have the totals for each of those in this sort of peach color right here. The total number of people surveyed, though, is always this number right here. It's always going to be this bottom right hand number, so that would be 240. All right, how many females were surveyed? Let's look at our chart here. So the females, or the women or girls, are all in this column right here. So what we want to do is we want to find the total for just that column. There were 16 females that were surveyed. 16. In a class of 25 students, 80% of the students maintain an A average. So there's 25 total, and 80% of them maintain an A average. How many students don't have an A average? So let's make sure we understand what they're asking us for. They're asking us for the students who do not maintain an A average. So 80% maintain an A average. So what percentage would not have an A average? Well, 100% minus 80% would be, this is 20%. So if we find 20% of 25, then we would find out how many students don't have an A average. Well, first of all, we can cross out the -3, because you can have -3 students, so we know it's not 0. So it's either going to be 15 or 5. 20% of 25, I can use my scientific calculator. And all I need to do is do 20% of, and then it puts the of in there, 25, and that is 5. So that's our answer right there. And then I think this is our last problem. Yep, it is. Okay, according to the table, what is the relative frequency of students ages 10 to 13 who eat breakfast? Okay, so let's say you get to that question and you're not sure what relative frequency is. On slide 4, there's a link to my digital notebook, and I just wanted to show you guys this and show you how you could find relative frequency. If you go to my digital notebook, go to slideshow. It's easier to watch in slideshow mode. And on slide 4, I told you this is unit 6. So go to unit 6, that means go to tab 6. And let's see, we have relative frequency is lesson 7. And these are all the notes on relative frequency. You can go to the video and watch that, or you can just go through the slides and look at the definition for relative frequency. So let's see, those are the warm-ups. So relative frequency, while frequency is the number of times that something occurs, relative frequency tells us the number of times it occurs compared to the total. So this says, in a survey of 50 people, 23 individuals answered their favorite ice cream was vanilla. What was the relative frequency of individuals who chose vanilla? Express your answer as a ratio and as a percent. Well, 23 individuals out of 50 people, we divided there, 23 out of 50, and that was 46%. So the frequency is the number. The frequency is the 23. The relative frequency is the percentage. So I just wanted to show you this so that you know that you can go to the digital notebook and you can find this a particular lesson and look at all the slides that we did, or you can watch the video of me teaching the lesson. So let's go back to our problem. So they're asking us for relative frequency of students ages 10 to 13 who eat breakfast. So let's look at our table. Students ages 10 to 13 is this row right here. And then eat breakfast is this column right here. So that would be a 40, okay? The 40 is not what they're asking us for. They're asking us for the relative frequency. So they're asking us for the frequency of the students 10 to 13 who eat breakfast compared to the total number of students. So then going back, we're going to, oh, let me get my marker again. So that would be 40 out of 90. And the way to find that percentage is just to divide 40 divided by 90. Okay, that is 0.44, and the 4 repeats, so we would round that to 0.44. And to make that a percentage, you just move the decimal 2 places to the right, and that is 44%. So it's going to be, our answer is going to be about 44%. So relative frequency is the percentage and not the number. And that was it.